Okay, so we've talked about projectile motion. Now we're going to talk about a subject, relative velocity. It's kind of an advanced version of things in physics, but it might be something that you see on an AP test. So I thought I'd spend a little time here on this. Now, so we're in a boat, and the boat is traveling this direction, but the river current is going in this direction. So these designations, this BW and WS and BS. But BW is the boat with the water. WS is the water with the shore, and the BS is the boat at the with the shore. So we're looking at different velocities here. But in the end, without looking at designations, the boat wants to go this direction, but the river's pulling it this direction. So this is going to be my resultant velocity. Again, it's just vector addition in the end of the day. So here's an example. A boat speed, okay, so a boat's speed in water is 1.85 meters per second, okay? So that's our BW. If the boat is to travel north directly across a river whose westward current speed, so our speed here of the current, or the water with the shore, is 1.20 meters per second, at what angle must the boat head to make sure we reach this position? Okay, so we want to take a look at what we can and see what we can come up with, and we want to use obviously something with opposite and with hypotenuse. Opposite over hypotenuse, right? SOHCAHTOA. So you got sine, you got cosine. Sine is opposite, so we're going to go opposite. So the sine of theta is opposite 1.20 over hypotenuse 1.85. I got to take the inverse sine of 1.20 over 1.85, and my theta, when I do all this math, is going to be a 40.4 degree angle. So that's the angle I have to take to make all this work. Okay, so let's think the same. So we got the same boat, all right, 1.85 meters per second. Now the current is still 1.20, but I want to head directly across. What is the velocity of the boat relative to the shore? So I want to find the BS of this. To find the boat to the shore, it's a real simple procedure. It's a right triangle, right? So I just want to use Pythagorean theorem. So I want to take BS is equal to the square root, or VBS is equal to the square root of 1.2 squared plus 1.85 squared. And this will turn out to be, when I math it all out, 2.21 meters per second. So that's the velocity I'm going to have if I'm traveling 1.85 due north and the currents take me 1.28 to the west. This is the actual velocity I'm going to have. Now, the next question, part B, is if the river is 110 meters wide, how long will it take to cross, and how far downstream will the boat be then? So I got to find my distance. And to find my distance, right, downstream, we're talking about going this way, okay? And so to do that, I have to think about just this part of the current, the 1.28. Remember, they're independent of each other. This is traveling this way, but this is pulling me down the current. This speed, your BW's velocity, has no bearing on how far down you go. It doesn't. You just have to know time to get there. And so if I want to know time to get there, then I have to do a little bit of figuring to get there. So time to get there is I have to look at my distance across, right? It's 110 meters. So how long does it take me to go 110 meters if I'm going that way? All right. So for B, the first thing I want to think about is this distance, okay? So velocity is distance over time, all right? And I want to find time. So time is distance over velocity. Excuse me, my distance is 110 meters. My velocity is 1.85. I do all this math. I get 60 seconds. So it takes a minute to make that trip all the way across. How far down will I be during that minute time? That's where I want to find my distance. So now I want to look at things in the horizontal. V is distance over time. Distance is velocity multiplied by time. My velocity is 1.20, and I'm multiplying that by my 60 seconds. And when I do that math, I get 72 meters. So I will go 110 and then 72 meters downstream, or however far that is. The thing to keep track of is just like projectile motion, keep your X and Y separate. But of course, time will be the one that pairs them all together.